Hello everyone. Welcome to the third section of this course, which is implementing classification techniques using TensorFlow. In this section, we'll learn all kinds of techniques of TensorFlow and know about all of these by doing two hands-on projects step by step. One is we'll figure out whether a person have diabetes or not by analyzing that person's other medical records like glucose concentration, blood pressure, etc. And the second one is we'll create a classification model using census data which will classify a person whether his or her salary is less than 50k or greater than 50k. Performing classification techniques on Pima Indian's diabetes dataset part 1. Okay, so this is our Pima Indian diabetes dataset that we will work on, and that is basically medical records of some patient. If you want to know more about that dataset, I will add full description of that in the course resource section. So feel free to check this out. Okay, here we can see that this dataset have 10 columns and the column name class is our label in this classification task. And rest of the columns will be our feature columns. So you might have guessed what we are going to do. Well, we'll try to teach machine to figure out the relationship between our feature columns and train them that. Then our model can predict the labels, that is class 1 if the patient has diabetes and class 0 if the patient has not any diabetes. Okay, so here we are going to do the following. First, we'll import the Pima Indian's diabetes dataset. Then we scale or normalize our feature data and bring them all in a same scale. After that, we will create our feature columns, and here we will know two important techniques of how to deal with categorical columns. One is vocabulary list and another is hash bucket. Very important concept that you need to know. Okay, then we'll import matplotlib library to visualize our one of the feature, which is age, and we'll learn another important concept, which is to convert a continuous feature to a categorical feature by using bucketized column. So some great things coming in a while. Okay, so without further ado, let's hop over to the Jupyter notebook and code this out. Okay, first we'll import our dataset. So let's type import pandas as pd, and then we'll create a variable that is diabetes is equal to pd.readcsv, and in parentheses in code we'll give the name of our dataset, that is Pima Indian's diabetes.csv. This dataset will be included in the course resource section. So check this out. So let's look at the head of our dataset. Type diabetes.head. So you see that is the table we saw before. Okay, normalize our column to bring all the feature column in the same scale. And that is so important in terms of efficiency. If you do that, bring them all in the same scale, then it would be a lot more easier and faster for our machine to process all this mathematical computation. Okay, first look at our columns. Type diabetes.columns. So this is all the column names here. Okay, now I am copying those column names and paste it here in calls to norm for our convenience. Here we don't include class because this is going to be our level, and we also don't include group and age because we have to work on it before we create our model as a data preprocessing step. We will normalize our dataset without using Python library. You can do that by using Python library very easily, but in order to know how normalize happen under the hood into our dataset, I think this will be helpful to you. And later on we'll see how to deal with that by using Python library. So we'll do that by using one of the apply family function, which is lambda. Okay, type diabetes square bracket, here we pass calls to norm is equal to diabetes, again square bracket calls to norm dot apply, and in parenthesis lambda x colon in parenthesis x minus x mean divided by in parenthesis x max minus x mean. So run that. Okay, let's check out the head of our dataset again, and you see all of our data are now normalized. Okay, now it's time to create our feature columns. Let's type import TensorFlow as TF. Then if we want to see the diabetes columns again, let's type diabetes.columns. So here are the list of all the columns of our dataset. So here I will make one variable for one of our numeric column, and for the rest of the numeric column I will fast forward the video. Okay, let's type number of pregnant is equal to tf dot feature column dot numeric column, and in parentheses in code we'll pass the column name number pregnant. Okay, this is all of our 8 numeric feature columns. Now let's move on. Now we'll deal with one of our categorical column, which is group. I know there are 4 groups available here, that is A, B, C, D. So we can assign this group by 2 ways. One is using vocabulary list and another is using hash bucket. We'll see both ways. Okay, first we'll look at vocabulary list. Type assign group is equal to tf dot feature column dot categorical column with vocabulary list, and in parentheses here you first pass the column name, that is group. Then in a list you will pass those 4 category you know. That is useful when you know how much category already exists in the whole dataset. So here we will pass A, B, C, D. But suppose you don't know how many types of category exist in your particular column. Suppose you may have a dataset where a column is like a country. So there are so many countries may be available in your dataset and you don't know how much country are there in it. So then you can use hash bucket system. So let's type assign group is equal to tf dot feature column dot categorical column with hash bucket. Then we first pass group and the second parameter is hash bucket size. So this is very useful component. Here we can assign a number which represent the maximum type of category you think exists in your dataset. So here let's say hash bucket size is equal to 10. Okay, so this is the another way. I am commenting this out because we did that before with vocabulary list. So let's move on. Now we'll do another interesting thing. You see here is a numeric feature column, but now let's say we'll convert it to a categorical column. Like we'll represent age like a range, like 20 to 30, 30 to 40 or 40 to 50, like that and so on. So okay, let's do that. Type import matplotlib.pyplot as plt %matplotlib in line. Then type diabetes square bracket in parenthesis age dot hist and in parenthesis bins is equal to 20. So here you can see most of the patient are between age 20 to 80. So let's bucketize that. Let's type age bucket is equal to tf dot feature column dot bucketized column. So this is a way of bucketize numeric values in a category. So then in parentheses pass source column is equal to age and boundaries is equal to the boundary you want to have. Let's say square bracket 20, 30, 40, 50, 60, 70, 80. Okay. So lastly, after finishing all of these data preprocessing steps, finally we will create our feature columns. So let's type feed calls is equal to square bracket number of pregnant, comma plasma glucose, comma blood pressure, comma triceps, comma insulin, comma BMI, comma pi degree, comma assign group and comma age bucket. So this is our feature column. Okay, this is the end of the first part of this classification project.